This tutorial shows you how to test if two species distribution models are significantly different from each other, implying that the two species have different ecological niches from one another. This tutorial assumes you have RStudio installed. See the show notes below for another video that I made to install it. This tutorial also assumes you have the R package ENMTools installed. See the show notes below for another video I made how to install it. This tutorial assumes you are using Ubuntu Linux version 20.04 as your operating system. If you do not have Linux, you can emulate it on your Windows computer for free. Older Mac computers can emulate Ubuntu Linux for free as well, but newer Mac computers containing the M1 chip will require you to purchase the software Parallels for about $50. See the show notes for details. I am emulating Linux right now on my older Mac computer using VirtualBox. I have VirtualBox virtual machines pre-configured with the software I will show you today, as well as other population genetics and ecological niche modeling software. But again, VirtualBox will only run under Windows machines and under older Mac machines before the new M1 computer chips. See the show notes below for step-by-step instructions to download and hook up this virtual machine within your Windows or older Mac computer using VirtualBox. Let's go ahead and get started. First, open up a browser window, which I have pinned to my favorites on the left or which you can find by searching below. Navigate to my website, joshbanta.com. Click on Tutorials. Type Control F to pull up a search window, and then type in 2 species. And then close the search window so you won't lose your place. Click on How to test whether two species distribution models are significantly different from each other using ENMTools in R. There's an older version of this tutorial that uses the standalone version of the ENMTools software, but it is more cumbersome and has many more steps. Next, select Files Needed for Tutorial. Click the Download button. Once the download is complete, you may close your browser. Next, navigate to your Downloads folder by clicking on File Explorer, which I have pinned to my favorites on the left or which you may find by searching below. From within your Downloads folder, find the file that we just downloaded called nichecompare.zip and double-click on it. This opens up the zip file using a program called Archive Manager to look inside of the compressed zip directory. We cannot run the files from within this compressed directory. We need to move them out. Go back to your File Explorer, navigate to your desktop, and from your desktop, choose the drop-down arrow for New Folder. Name your new folder Niche Compare and click on Create. Next, double-click on the new folder Niche Compare. Now, go back to your Archive Manager software. Click on the first item within the zip archive. Then, go down to the final item in the zip archive. First, hit the Shift key. Then, regular click on the last item in the zip archive. With all of them highlighted in orange, regular click on one of these icons on the left and drag all of the items into the folder you have created on your desktop in your File Explorer. We have now uncompressed the files that we need from the zip archive, and we can close the Archive Manager software.
This is a quick splice to ask you to consider subscribing to my channel by hitting the subscribe button. It does not cost anything. It is totally free. But if you like what I am doing and want to support my work, I encourage you to visit patreon.com/joshbanta and make a voluntary contribution. The link is in the show notes below. Your support helps me to deliver new content and keep this channel current and vibrant. Thank you.
Before we get going on the main laboratory exercise of testing if two species distribution models are significantly different from one another, I have a few toy exercises to help you to understand what we will be doing. Double-click on the file fruitweights.xlsx. This will open in LibreOffice Calc, which is the open source version of the Microsoft Office suite of programs. Uncheck Show Tips on Startup and click OK. One slight problem is that we cannot see everything that I have set up within this spreadsheet. Go to View, Zoom, Entire Page. But before I explain what I want you to do here, I want you to click on this tab that says Jackfruit Photo. This is a fruit called jackfruit, which is native to Southeast Asia. There's not a lot I want you to know about it except that the fruits of the jackfruit tree are very large, as you can see in this photo. Contrast that with clicking on this second tab of table grapes, and as we are all familiar, table grapes, each one of these is an individual fruit. So compare each one of these individual grapes to an entire jackfruit, and you can see that an individual grape is much smaller than an individual jackfruit. And in fact, jackfruits weigh much more than individual table grapes. Click on the tab that says Permutations. So I have set up this table here with the weights of 10 different table grapes in grams. And you can tell that this is the weight of individual table grapes because the weights are so small. Here I have the weights of 10 individual jackfruits, also in grams. You can tell that this column is the weight for jackfruits because the individual weights are so large. At the bottom of each of these columns I have the averages. So the average weight of these table grapes is 2 grams. The average weight of these 10 jackfruits is 3,565 grams, much larger. I've also made this bar graph to show the two average weights. Here you see the average weight of the jackfruits. You cannot even see the average weight of the table grapes because comparatively it is so much smaller than the average weight of the jackfruits. This overall scale of the graph is so large that we can't even see the bar graph for the average weight of the table grapes, which is 2 grams. Here's what we're going to do. We are going to permute the data, meaning that we're going to mix it up. To do this, I have a random number generator. To activate the random number generator, in the cell directly to the right, type in the number 1 and hit enter. The random number generator has picked for me the number 10. For you, it will have picked a different row. If it picked the number 0 for you, come back here, type in 1 again, and hit enter. And always do that so that you never have the number 0. So now I have row 4. So I'll just start with row 4, but you start with whatever row this number is telling you to start with. So I look in here for row 4. Don't look at the numbers here on the side. Look at the row numbers in the table that I have created. In row number 4, the table grape has a weight of 1 gram. And the jackfruit has a weight of 8,108 grams. The easiest way to do this is to come down here to the bottom and type in those numbers again. 8108, and then here we have 1. Then we'll come back in here, and what I want you to do is switch these two around. So I want you to take this one and make it 8108. And I want you to take this one and make it 1. Now be careful because I'm working with row 4. In your case, you'll be working with a different row. Whichever row you were working in, you should have copied the numbers down here and flipped them around in the corresponding row. So you shouldn't have done exactly what I did. You should have done according to whatever row number that you had. All right, as you can see, the act of entering in the numbers in these cells moved the random number generator to another number. So now we can use that new number, in my case, row 1. For you, it's whatever the new row number is. Now, it could be the same row number that you had before. In that case, switch the numbers back. But in my case, it's row number 1. So I have 5354, and again I have 1. So I'll go into row 1 and I'll switch those around. 5354, and in the second column I'll put 1. So I flip those around. And now the random number has chosen for me row 6. So now I'll do the same thing for row 6. But in your case, do whatever the random number row is telling you to do. Don't follow me literally in the tutorial. So then in the second column of row 6, I have 1754. So now I'll come into row 6 and I'll flip those around. And now it's given me row 5. So in row 5, I've got 6 and 64. So I'll switch those around. Now again, it is okay if the random number generator chooses the same row for you 2 times in a row. If it does, simply do as you've done here all along and record what numbers are currently in the corresponding rows for that column, in the corresponding columns for that row. And then flip them back around. And I want you to do this a total of 30 times. Here's mine once I got to 30. Yours will look different from mine because the random number generator will have picked different rows for you to swap. And I know I got to 30 because I counted how many swaps I did over here. And now look at how different the averages are. So this was originally our table grapes, and this was originally our jackfruits. Now that we've swapped everything around, look at what the average is. The average now is 2,413 grams for the table grapes and 1,154 for the jackfruits, because we've swapped around so many of the numbers. You can see that also represented here on the bar graph. Of course, yours will look different from mine, but the two bars will both be visible now, as opposed to before, where one of the averages was way bigger than the other. This is called a permutation analysis. And a permutation analysis is used to create a null distribution to which you compare your actual results. And if your actual results are more extreme than the permuted results, then you can say that the difference between the two averages of your actual results is significant. So this is called a permutation test. And we have here 2,413 for the table grapes and 1,154 for the jackfruits. And that was for the permuted results, compared to our actual results, where it was 2 grams for the table grapes and 3,565 grams on average for the jackfruits. So compare the actual results and look at how extreme the difference is in the weights between the jackfruit and the table grapes on average for the real results versus the permuted results. And again, your permuted results will be different. But look at how much smaller the difference is in the average rates between the table grapes and the jackfruits when we use the permuted results. So the difference between the weights of our table grape and our jackfruit on average for the real results is so extreme as compared to the smaller difference for the permuted results that we can say that the difference in weights for table grapes versus jackfruits for our real results shown here is significant. It's a significant difference. It's a statistically significant difference in the weights on average between jackfruits and table grapes. You may now close LibreOffice. Next, we're going to do a couple of quick ecological niche models, by which I mean species distribution models. Click on the Niche Compare folder on your desktop. And then double-click on the folder that says Maxent. If you are on a Windows-style mouse, right-click on the Maxent.jar file. If you are on a Mac trackpad, push down with 2 fingers. Select Properties. Click on the tab for Permissions. Check the box that says Allow Executing File as Program. Then close the window. Now double-click on Maxent.jar. I have another tutorial showing you how to use Maxent in great detail. See the show notes below for details. This will be a short modeling exercise comparing the species distribution modeling of 2 different species, specifically the 5-lined skink and the Texas horned lizard. The occurrence records of the 2 species come from iNaturalist.org, a citizen science database where individuals record the observations that they make of particular species along with photographs and other information, and experts will decide if those are in fact the right species Then you can download research grade observations that have been verified with the GPS coordinates of those occurrences. The environmental data comes from the WorldClim Climate Consortium. Specifically, we are using the bioclim layers of recent historical climate from every place in the world. A couple more points to note. We will not be using a bias file. These occurrence records have already been thinned so that there is no more than one occurrence record every kilometer. And we will not be using all 19 of the bioclim variables because some of them are highly correlated with others. And I have already removed highly correlated bioclim layers. I have a tutorial about that which you can find in the show notes below. For this simpler, quicker version of species distribution modeling for the purposes of this tutorial, follow along with me. Click on Browse. Navigate to your desktop. Double-click on the Niche Compare folder, and then double-click on the folder that says Species. Choose combined2.csv and click on Open. This loaded the species occurrence data for the Texas horned lizard and the 5-line skink simultaneously. Maxent will run separate species distribution models for each of these two species. For the environmental layers, click on Browse. Now we need to navigate back up in the hierarchy, so click up one level. Then select the Layers folder, but don't double click on it. If you accidentally double clicked on it, select up one level. Just click on the Layers folder without double clicking on it and click on Open. These are all of the layers that we're using. Again, I've removed the ones that were highly correlated with others. Keep the box checked that says Auto Features. Keep the box, for the purposes of this tutorial only, Create Response Curves unchecked. And do Jackknife to Measure Variable Importance, keep it unchecked, because we won't be looking at that in this tutorial. Next, for the output directory, click on Browse and select the Results folder within the Niche Compare folder and click on Open. Now click on Run. It will not take long as I've designed this tutorial data to run very quickly. Once finished, come back to File Explorer, navigate to the Niche Compare folder, and double-click on Results. Within Results, find skink.html and double-click on it. Here we see the species distribution model for the 5-line skink based upon the data provided. You can see that the areas of highest habitat suitability are on the East Coast, with some pockets in the southeast, near where we are located in East Texas. Now, within that same folder, find the file hornliz.html and double-click on it. Now we've got two different tabs open, and we can now see the species distribution model for the Texas horned lizard. And as you can see, it looks quite different. So if we go back and forth, so this is the Texas horned lizard, where the areas of highest habitat suitability are centered on West Texas and South Texas, versus the 5-line skink, where the suitabilities are centered around the northeastern United States and Appalachia, as well as the southeastern United States. Horned lizard, 5-line skink. Horned lizard, 5-line skink. These two species distribution models look very different, don't they? In order to make it quantitative and not qualitative, we need to use statistics to determine if the difference in these two species distribution models is statistically significant. And we will be doing this with a permutation analysis like the one I showed you for the fruits. So I used the one with the fruits as an example of a type of permutation analysis. To show you what will happen when we permute the data, I want you to try it. Eventually, we will be doing this all with computer software. But so that you know what the computer software is doing, I want you to try this permutation manually. Go ahead and close Google Chrome. Go ahead and close Maxent. Navigate back to the Niche Compare folder on your desktop. Next, open RStudio, which you can find pinned to the favorites on the left or by searching below. Click on File and select Open File from the drop-down menu. Navigate to the Niche Compare folder on your desktop and select permute.r and then select Open. This is a very simple R script that is a random number generator. So let's highlight it and click on Run. So it's given us two numbers here. Your two numbers will be different than mine. My two numbers are 10 and 19. Don't pay attention to what my numbers are if you're doing this on your own. Pay attention to what your numbers are if you're doing this on your own, because you will get two different numbers from this random number generator. Go back to File Explorer. Go into the Niche Compare folder and double-click on Species. Within the Species folder, highlight combined2.csv. With a Windows-style mouse, right-click. With a Mac trackpad, push down with 2 fingers, and select Copy. Now, highlight an empty space within the File Explorer window that you have open, and right-click in the empty space on a Windows mouse or push down with 2 fingers on a Mac trackpad and select Paste. So we have now made a copy of our species occurrence data that we can safely work with. Double-click on it. Click OK to open it in LibreOffice Calc. That is really hard to read, so I'm going to do View, Zoom, 200%. That's much better. Now I will go back to look at RStudio. RStudio, the random numbers chosen for me were 10 and 19. Going back to LibreOffice Calc, here is row 10 of the horned lizard. I'm going to take the data here and I'm going to highlight it, both columns, and then I'm going to right-click on the highlighted data with a Windows-style mouse or push down with 2 fingers on a Mac trackpad, and I'm going to select Cut. And I'm just going to move to this cell here right next to it and click on it, and within that cell, right-click Windows-style mouse, push down 2 fingers Mac trackpad, paste. Okay. The other number I had was 19. So that is row 19. So I'll come down to row 19 and I'll highlight that data. And I will cut it. And then I'm going to click on just this one cell here. I'm not highlighting, just this one cell up here. And I'll paste it in. Then I'll take this data, cut it again, and paste it down here. So I've swapped those two data points around. I want you to do that using your own random numbers that you generate 30 times. So come here, highlight it again, click on Run. Oh, I did it 2 times in a row. But anyway, now I will swap 9 and 16, and then I will swap 9 and 19. But wait, you may be wondering, I've already done a swap with row 9. That is okay. Do whatever the random number generator tells you each time for 30 times in a row. Notice that I'm only swapping the GPS points around, not the species identities. I want you to do that a total of 30 times. One thing I forgot to tell you is that for this permutation, use the row numbers in gray on the left. I didn't make my own row numbers. Use the ones here. I have the R script set up to correctly identify all of the row numbers of the data. So use the hardwired row numbers provided to you by LibreOffice Calc when identifying the rows for the swaps. Okay, once you've done it 30 times, which you can see here by counting, save your work by going to File, Save. When prompted, select Use text.csv format. And now you can close LibreOffice. And now you can close R. Click on Don't Save. And now we will run Maxent again. Come back here to Niche Compare, double click on Maxent. We'll double click on Maxent jar. Now for our species occurrence data, this time we will use combined to copy. So remember, we still have our 5-line skinks and our horned lizards, but we have mixed up the GPS points so that some of the horned lizard GPS points are attributed to the skinks, and some of the skink GPS points are attributed to the horned lizards. It's all jumbled. The statistical term for that is permuted. But we're still going to generate 2 species distribution models. For the directory of the environmental layers, go back to Layers and click Open. Make pictures of predictions. Now careful here, we do not want to save to the same output directory. Click on Browse. This button here says Create New Folder. Click on it and name the new folder Results2. And click on Open. Now click on Run. Let's look at our new results. Navigate back to the Niche Compare folder on your desktop. Navigate to Results2. And let's start again with skink.html. Remember, this is the one where the most suitable habitat was found on the East Coast and into Appalachia, with a pocket of suitable habitat in the southeastern United States. Well, now it doesn't look that way at all. Now we see distributions throughout the throughout the extreme southern United States, and also into Arizona. So we see a completely different distribution. Let's compare it to the one that we had for the skink before. Well, come back to niche compare, go to results, and then go to skink.html from the original results and double click on it. So here's the actual species distribution model for 5-line skinks. Here's the species distribution model for 5-line skinks that's based upon permuted data. You can see that they're very, very different. Now let's look at the Texas horned lizards. Go back to niche compare, go into results 2. This is the permuted results. And select hornliz.html. Remember that the actual species distribution model for the horned lizard has their distribution centered on west and southern Texas. But that's not the case here at all now. It's still somewhat centered on west and southern Texas, but not nearly as much as before. Let's pull up the species distribution model from before. Go to niche compare. Yours will look different because your random number generator resulted in different permutations. Go to results, double click on hornliz.html. So here are the actual results, and here are the permuted results. Actual, permuted, actual, permuted. So now let's compare the permuted results of the Texas horned lizard to the permuted results of the 5-line skink. So here's the permuted results for the Texas horned lizard. Here's the permuted results for the 5-line skink. We can still see some differences, but it's not as extreme as it was before. Compared to the original differences, here's the actual species. Here's the actual species distribution model for the 5-line skink. And here's the actual species distribution model for the horned lizard. Here's the permuted species distribution model for the 5-line skink. Here's the permuted species distribution model for the Texas horned lizard. There's a lot less difference there as compared to the original 2 niche models. Look at how much different they are from each other. So if we compare how different the species distribution models are for the skink and the lizard, the horned lizard, with the actual data, compared to how different the models are for the permuted data for the skink versus the horned lizard, we can see that the difference in the species distribution models for our actual data, that these 2 distribution models are much more different than the permuted distribution models are from one another. So because this difference here, this is the real data, is so much bigger than the difference in the species distributions based upon the permuted data here, we can conclude that the difference in the species distribution models for 5-line skinks and Texas horned lizards is statistically significant. The thing that's missing from what you just did is that we do not have a number to attach to it. For statistical significance, you usually want to quantify it with some sort of a number. And ENMTools will go through this procedure that you just went through, except it will do what you just did 100 times. So it will permute the data, but it won't just do what you just did like that, which took you all that time. It'll do what you just did like that, where you moved stuff around 30 times, but it's going to do that whole thing again and again and again and again and again 100 times. So it'll do a lot more. And it'll give us a number that we can use to make a discrete decision about whether the difference in those species distribution models is statistically significant or not. Go ahead and close Google Chrome. And go ahead and close Maxent. Open up RStudio again. Select File, Open File. Navigate to the Niche Compare folder on your desktop and select ENMTools.R and select Open. And by the way, we can close this Permute tab because we're done with it now. The first thing we have to do is to set our working directory. Click on Session, Set Working Directory, and select Choose Directory. Navigate to your desktop. Do not double-click. Highlight the Niche Compare folder on your desktop and select Open. We have now set the Niche Compare folder as our working directory. Remember that this tutorial assumes that you have already installed ENMTools. All we have to do now is load ENMTools. We do not need to install it. Highlight line 7 and select Run. I want to point something out. Notice that within the Niche Compare folder on our desktops, there's a folder called Layers. It is in this folder called Layers that we have our environmental layers. We also have a folder called Species, and it's in this folder called Species where we keep our species occurrence locations. And pay very careful attention. I'll just open this now so that I can show you. To the formatting that I used. Species, all lowercase, longitude, latitude, and I put both species within the same CSV file. So if you're doing this on your own data, you will want to have your data set up exactly like mine, although you can have more entries in this. You will want to have it set up exactly like mine so that the script will work with your own data. And you have to put your data in the same folders as I did for this tutorial. So your environmental layers have to go into a folder called Layers. Next, we will import our raster layers. If you were using your own data, you would change these raster layers to be the names of the raster layers that you have for your own data. And you'd want the object names of your imports to reflect the object names of your actual data. So remember that this is something that you would need to change if you were bringing your own data to this tutorial. Highlight these lines of code and click on Run. Next, we have to do something called stacking these rasters. So highlight that line of code and click on Run. This takes all of the raster objects and puts them together into one stacked object within R. Next, we will read in our occurrence locations. The name of the occurrence locations in this tutorial is combined2.csv. Although if you were using your own real data, you would change this name here to reflect the name of your actual CSV file that contains your species occurrence locations of both species. Click on Run. Now we need to do some things to format our data for ENMTools. So that's lines 31. Well, let's just run lines 31 through 41. Make sure everything is fine. Everything is fine. And now let's run lines 45 through 46. This is more formatting for ENMTools. This line of code here will create a directory for our results if you don't have one already. Don't worry about this error. This is just because the folder already exists. Line 54 is where you set the number of replicates. This is how many times ENMTools is going to completely do the analysis again, all over again, using permuted data. So it's not just going to do it once like we did. You say, wait, but I moved stuff around 30 times. Yes, but that only counts as one permutation. ENMTools is going to do something like that, but it's going to redo that 100 times. So imagine all the work that you just did times 100. Yes, think about all those 30 steps, but imagine all of those 30 steps and doing that again and again and again, those 30 steps again and again and again 100 times. That's what we're telling ENMTools to do here. With your own real data, you could set this number of reps higher if you would like. This is to set the number of background points for the species distribution modeling, which you would normally want to set at 10,000. To make it run faster, I have it set in this tutorial as 1,000, but if you were doing this on your own data for a real study, you should bump this up to 10,000. Oh, so let's run those lines of code. So 54 to 58. Click on Run. Now we're going to perform the statistical test itself. Which is lines 62 to 75. Make sure you get the whole thing highlighted from beginning to end. Don't leave out any letters or you'll get an error. Click on Run. You'll see a progress bar. I'm at 7% finished, but this will take some time. All right, finished. That took over 20 minutes. These warning messages are normal. Do not be afraid of them. Next, we need to write the raw results to a file. Highlight line 79 and click on Run. Next, run line 83. Line 87 is very important. This is the critical value that you want to use to decide if your results for your two species are significantly different from the permuted results. Let me show you the raw permuted results. D and I are two different measurements of how similar or dissimilar two species distribution models are. Numbers closer to 0 mean that the species distribution models of the two different species distribution models are very different from one another. Numbers close to 1 mean that the species distribution models of the two species are identical to one another. And so a high number closer to 1, such as 0.9, would indicate that the two species distribution models are very similar. So these are two different ways that are typically measured in terms of the species distribution model similarities. But you can see that in both cases the numbers are low. So we're paying attention here to the empirical row. This is the real results. This is the real results comparing one species distribution model to the other. So their similarity is only 0.14 according to the D metric, or only 0.3 according to the I metric, which means that the two species distribution models are pretty different from one another. Now, this D metric is comparing both species distribution models. This I metric is comparing both species distribution models. So don't get that confused. There are two different metrics for comparing two different species distribution models. Now these replicates, 1 through 100, are based upon the permutations. So ENMTools did something similar to what you did and permuted the data, ran the species distribution models for the two species with the permuted data, and compared their species distribution models, and calculated the D and I statistics based upon those comparisons. And what you can see is that the results are different every time. Each one of the 100 runs, the results are different. And that's because the permutations are based upon random numbers, so the permutations are different every time. But you can also see that the permuted results are much higher than the real results. So the similarity calculated between the two species distribution models was pretty low, here too, as compared to the similarities between the species distribution models based upon permuted data. So how different does this real D statistic have to be from these permuted D statistics? And what about the fact that every one of these D statistics based upon a different run of permuted data is different? Well, what you do in this situation is you decide, I want to compare my real results to the 95th percentile of the permuted results. What does that mean? Which of these numbers is so low that 95% of the other permuted results are higher than it? So you look for a number where 95% of this list are higher than it. And that number becomes your critical value. And you compare your critical value to the real results, to the empirical results. Now you can set that critical value at the 95th percentile. You can set that critical value at the 90th percentile, at the 70th percentile. You can set that critical value wherever you like. Traditionally in the literature, you set that critical value at the 95th percentile. So which of these replicate runs using permuted data is such a low number that 95% of the other permuted data values are higher than it? So let's go back to R. If you were using your own data, you could change this percentile to anything you like, but I recommend leaving it at 95%. So highlight the lines of code from 87 to 91 and make sure you don't leave anything out, and click on Run. Next, to finish things off, highlight lines 95 to 108 and click on Run. And this generates an important file called results_summary.csv, which shows us the results that we're interested in with a user-friendly view. Click on File Explorer, navigate to your desktop, and go to Niche Compare folder, and click on the ENMRes folder, meaning ENM results, and then click on ResultsSummarycsv. Click OK. So and then rank correlation is another way that sometimes people will use, but I don't pay it any attention. But it's here in case somebody ever asks you for it. It's another way to measure the similarity of two species distribution models. But we'll just focus on D and I. So for D and I, for our real data, this is how different the two species distribution models were from one another according to the D statistic. This is how different the two species distribution models were from each other according to the I statistic. Now the permuted critical value, meaning that from the 100 replicate runs that we did, the D statistic, where 95 of the other runs had D statistics higher than that, was 0.61. Similarly, the critical value for the I statistic was 0.85. So here's what you do. If the empirical D statistic is lower than the permuted critical value, then your two species distribution models are significantly different from one another. If the empirical D statistic is lower than the permuted critical value, then your two species distribution models are significantly different from one another. Similarly, if you want to go by the I statistic, if your empirical I statistic, based upon your real data, is lower than the permuted critical value of the I statistic, then you consider your two species distribution models to be significantly different from one another. An important point to make here: this analysis that we did does not tell you whether or not your species overlap. The two species may still overlap, and may still overlap a lot. The question is not whether the species overlap, and this analysis does not answer that question. The question is whether, regardless of how much the two species overlap, are they at all different in their habitat preferences, even a little bit. This analysis answers the question, are the two species different in their habitat preferences, even if they're only different a little bit? This analysis does not answer the question, do these species overlap? Please keep that in mind. One more point. I often have people reach out to me when I post these videos asking for citations. They would like to see text describing these methods in a peer-reviewed scientific journal article, that they can use that text in their own writings, and so that they can cite that journal article where that text appears. Go to joshbanta.com. Click on Publications, and find the publication from the year 2021 that's published in the Journal of the Botanical Research Institute of Texas, and click on PDF. Wait for the paper to load. So in this journal article, I used the same method that I just described to you here. If you come to the bottom of page 289, you can find a description of the methods that we went through in this tutorial, along with the relevant citations. The only difference is that we did not use the standalone program ENMTools. We used the ENMTools package in the program R. So with that one minor modification, the rest of the text you see here describes what we did in this tutorial. So to summarize, whether you are using the D statistic or the I statistic, our two species distribution models, the one for five-line skinks and the one for Texas horned lizards, are significantly different from one another because the empirically derived D statistic measuring the similarity of those two species distribution models is low, as compared to the permuted critical value. So because this number measuring the difference between the two species distribution models is a lower number than the critical value, it means that our two species distribution models are significantly different from one another. Now, if this number were larger than the critical value, then we would conclude that our two species distribution models are not significantly different from one another. Notice I emphasize I have not said anything about overlap because this analysis tells you nothing about whether the species overlap or not. Never use the word overlap or anything that means overlap. This analysis shows you whether the two species distribution models are different from each other or not, which is different from talking about overlap. So there you have it. You have now completed this entire tutorial.